Tonight we have the pleasure of welcoming as our speaker Corey Noxon, Assistant Professor at the Ritsumeikan Global Innovation Research Organization, R-GIRO, here at Kinugasa campus. Dr. Noxon earned his PhD in archaeology here at Ritsumeikan, writing on population and mobility in the Middle Jomon period as viewed from architectural and skeletal remains. He has also worked at the Lake Biwa Museum. The title for tonight's talk is Fit to Scale, Photogrammetry Project Considerations for All Shapes and Sizes. And with that, I'll pass it on to you.
Okay, on video here, let me share my screen. All right, okay. So let's, as I said, a Fit to Scale Photogrammetry Project Considerations for All Shapes and Sizes. Already kind of went through the introduction a little bit here. Again, I'm an archaeologist here at Ritsumeikan University. Some of my research focuses are on the Jomon period, residential mobility, population dynamics, and pertinent for this presentation, 3D applications in archaeology. As I go through this presentation, I'm going to talk about different photogrammetry projects at different scales. But at each scale, I'm going to talk about some of the related research projects associated with them. As part of the process of planning for a photogrammetry project, kind of understanding what you're wanting to do with the data, what some of the outputs are, is a really important aspect of that process. So I'm going to kind of bounce back and forth a little bit as we go along. Talking about kind of different sizes related to kind of archaeological work. Kind of on the smaller scale, I'll deal with artifact scanning. A couple examples are the Ozaki lakebed site up in northern Biwa, or the Sugisawa site, which is over in Shiga Prefecture, which we can see over here, where we focused on a digital reconstruction of a late Jomon burial pot, excuse me. Kind of going to a little bit larger, with like some smaller structure scanning. I've done a number of photogrammetry scans of Jomon pit house reconstructions, which were used for material and energy cost estimates. And kind of for broader, wider ranging scans, I've worked with some of the Jomon stone circle sites in northern Japan, and again for archaeological excavations at Sugisawa and Suwahara site in Yamanashi Prefecture. Just a quick overview in the very beginning, talk about photogrammetry itself. It's a process in which basically we're taking multiple images of an object and we're finding corresponding points between those images through the use of feature points, which are basically parts of an image where you can see kind of clear, recognizable, and points that are visible in multiple images. You combine those points across those multiple images, which are then used to calculate and plot the points in 3D space, kind of giving us our 3D model. Photogrammetry is applicable across a wide range of different physical scales, which makes it extremely flexible. As I said, for different project approaches, you'll be looking at a number of different factors. When I talk about object size here, I'm kind of talking about the target of whatever object or scene area you're wanting to scan. You're looking at whether that is something that's fixed, immovable, or something that's immobile that you can move around in order to scan. You look around at the desired detail that you want to try to capture. Is this kind of a rough scan kind of done with a drone covering a wide area where a detail or resolution of a meter is fine, or are we looking for something finer, centimeter, or maybe even millimeter scale precision? You also look at the different material properties of the object that you're scanning. Different tools and approaches for 3D scanning lend themselves to kind of different materials. They each have different strengths and weaknesses, and those are some things that you want to be aware of as you go forward with it. And I'll hit on this point a lot. You want to look at the desired data output, basically how these models are going to be used, how they're going to be processed or analyzed, and how this data is going to be shared later on. We're going to go kind of wide and work ourselves to kind of small scale here. So we'll talk about some of these wide-ranging large scans. I'll call them environmental scanning here, but this also works for larger interior spaces. A couple examples here in both corners. This is the Oyu Stone Circle site. This is the Washinoki Stone Circle site up in Hokkaido. This is the Suwahara site in Yamanashi, and the Sugisawa site in Shiga Prefecture. Again, for photogrammetry, you're going to be dealing with cameras, but there's a number of additional tools that you may be using. In terms of cameras themselves, if you're, again, dealing with these large spaces, you may want to go and use a drone of some sort. You'll be looking at maybe a consumer grade or a professional grade drone. The differences between there, kind of, you'll be dealing with different speed and resolution. Again, higher end units, you'll be able to scan faster, typically because of global shutter versus a rolling shutter that you would get in consumer drones. Again, for some of the professional drones, you may be able to just incorporate whatever DSLR or mirrorless camera you may normally use, just attach it to that and go. Of course, there's also differences in costs and size as well. Again, in addition to drone, you may have a DSLR mirrorless camera or possibly even a smartphone, depending on the type of scans you're doing. A flash system of some sort may be beneficial. A camera pole, which you can kind of see over here at Uminoki site, in order to kind of get some higher angle shots of what you want to scan. A color checker in order to be able to balance the image color later on, and then some scanning targets and markers, which I have examples down here, and I'll talk a little bit more about later. As I said, this is something, when we're talking about these large-scale scans, this is something that could be within a large interior space or outside. If it's inside, you may be able to control the lighting to some extent, which can be beneficial. You'll need to look around at your freedom of movement inside as far as how will you be able to move around and whether the areas that you want to capture are visible or not. Basically, if you're not able to see an area, you're not able to photograph it, record it, and it won't show up in your model. If you're dealing with outside, you'll be looking at kind of the size of scan that you want to be covering. If it's a smaller area, maybe a drone isn't necessary, but if it's a larger area, the drone can be helpful. Tying in with the drone, you're looking, and not only just the drone, but weather is a consideration. Not only as far as the sun and kind of shadows moving over time, but rain, wind, other things like that. You may be looking at whether an area is urban or rural. There are population density restrictions dealing with drone scanning that could cause some issues there, as well as being near government or military installations is another thing to be aware of. For an example, which a few different examples that I'll cover here, were tied into a Circles of Stone project. They had a visitor center over at Stonehenge where they wanted to introduce visitors to some of the stone circle sites within Japan here. So these are contemporaneous to some extent with Stonehenge itself. They put on a really neat project, and as part of my involvement with this, I did some different digital recordings of some of the sites up there. Kind of one of the simplest ones that I dealt with was the Washinoki site in Hokkaido. This is a fairly large site. Kind of particular interest in this case is it was actively being excavated, which means that trying to walk around could be a little bit hazardous. You can kind of see some of the different sheets around on the ground. You can't see as well, but a number of lines, different trenches. Time was limited for scanning this site, basically a single lunch break, so I had to work quickly. And overall, there was just a focus on the general site itself. Again, because it was actively being excavated, the interest wasn't as much on specific details. So kind of scale precision, that millimeter, centimeter precision wasn't quite as important in this case. So for this scan, I just used the drone itself. Again, you can kind of see one of the reference images and then the scan itself. I'll cover a couple images later on of it, but it worked out quite well. Going a little bit smaller here to the Sugisawa and Suwahara sites. These are smaller excavation sites, and this is for kind of individual or small scale researchers. This is often more of a scale you may be working at. These sites are again in Shigen Yamanashi Prefecture. I had the benefit of having more time to scan as well as time to do repeated scans of these sites. I had more control of this scanning area itself, which was beneficial. For these, again, because it wasn't just on visualization, but we wanted to try and use it for research purposes as well, scale and accuracy were more important in these cases. I combined drone scans and mirrorless camera scans with these, but while I'm touching this on kind of a broader scale right now, actually these sites were scanned at kind of multiple different scales. In order to try to tie those scans in together, I used some semi-permanent targets. Again, luckily because we had control of the site, I was able to do this, where basically some large camp stakes were nailed in around the outside of the sites that weren't going to be moving around in between scans. Benefit of that is I was able to tie these drone scans into the other scans later on, as well as scanning those individual trench scans with themselves, again, which I'll cover in a bit. I had done Sugisawa first and then went on to Suwahara later on. Tried to use the flash when possible at Suwahara, although rainy weather caused some issues. You can kind of work around with the camera a little bit. With the big flash system, you don't want to play around with water too much with that. These scans, again, kind of, as you can kind of see in the example picture, included the kind of surrounding immediate area, just to be able to put these sites kind of into a broader context. And as I said before, these were kind of scanned at multiple scales, which we'll talk a little bit later. Going back out to really big, to a very different kind of site and conditions, and back to that stone circle site, we've got the Oyu stone circle site in Akita Prefecture. This is quite a large site and actually includes two stone circles, the Manza and Nonakado stone circle sections. The Manza, which is this bottom picture here, is about 50 meters in diameter. But as you can kind of see in the upper site, this is the Nonakado, the Manza, and you actually go out all the way to that tree line. That's all included in the site. So overall, it's quite a large area. For this, we wanted kind of a broad scan, but I also wanted to try to really include some details of the smaller stones and stone features that made up the larger site. There were some limitations on how I could interact with the site as far as targets. I don't want to be nailing in big stakes, other stuff like that to a UNESCO World Heritage site. I want to be careful with that. However, again, since this scanning process took quite a bit of time, targets moving at any point in time throughout the scan could cause some problems. At this point in time, I decided to go without targets, which had some issues, which I'll talk about right now. There were some significant difficulties with alignment with this. Again, we've got a lot of grass and kind of natural stone features, which didn't provide a lot of clear feature points in order to tie things together. Additionally, the elevation, time was limited, so I took a broader, higher elevation sites, an intermediate one, but possibly an additional scan would have been helpful because trying to match features from the drone scans to the DSLR scans was tricky. It turned out, as far as natural features, that bird poop, bright white bird poop, was picked up quite well from drone scans, which you can kind of see here, as well as down on the ground. So that kind of saved me in trying to align this project, but kind of clearer targets would have been more helpful, definitely. In addition to kind of the stone features, The scans also included reconstructed buildings, which were processed later just due to the amount of data and images I was working with here. So the raw scan overall, when processed at high resolutions, was massive, over 5 billion polygons. This is just kind of a rundown of some of the different stone circle sites as far as the number of images and associated file sizes with them. Again, if we're looking at Oyu, at the Manza just itself, for the stones itself, 2,400 images, 1,300 with the drone, and then another 2,000 plus of the buildings. Again, the amount of data over time really tends to build up with these projects, which is something to definitely be aware of, and would be better to be aware of beforehand to really focus on the things you need to capture. On that topic, part of this process as far as taking these raw scans and getting them into a form that you're able to more easily deal with, data reduction is an important step. Here's a couple examples. Over here on the right, this is that 5.4 billion poly mesh, and this little section that's cut out of it here, as far as without reconstructing the rest, came to 1.4 billion. So still quite a lot of data. You can mesh on using a lower resolution, basically downsampled images, which is what I did here, which gave me a 1.5 billion poly mesh, a little bit better, but still pretty large. Pulling out a smaller section of that scan kind of gave this close to 300 million poly mesh here, focusing on the stones themselves. So we're getting into more manageable ranges. And going from this kind of larger stone circle section into an individual feature, right, this little square here is around 31 million polygons here, which you can see kind of over in this scan. And then later, that can be further processed and decimated down to get something under 1 million polygons, which is something that can more easily be shared online. Here's a couple images as far as how that feature was cleaned up. Again, trimming unnecessary sections. And actually in this, the stone features themselves were kept, but all of the additional grass ground was kind of replaced with CG assets in order to make things look a little bit cleaner. It has a bit of an artistic look to it, but gives you a good view of this feature itself. Talking about that decimation process, this is a little section from Washinoki. You can see kind of the raw scan is coming at over 400 million polygons, but the difference between that and a 1.8 million polygon version isn't that much. You can see that as far as if you're really zooming in and looking at particular geometric details, it's important. But if we're looking for just visualization purposes, there is a lot you can kind of get away with, especially when you add in textures over here. You'd have a hard time telling, again, without really going into the model to see a difference between the two. If you have a really big project, again, we'll use Oyu in this case here, that you're still needing to wrestle around with, another option is to try to subdivide it into smaller sections. At this point in time, I had already pulled out and all of the stone features here, so we're not seeing any grass or ground within the mesh, but the model was still quite large. So I ran an automatic script which divided it into 64 different sections. I have them kind of highlighted here so you can see some of the differences of them side to side. That made it much more manageable in order to do kind of some cleanup work with these individually, decimate them down to a more manageable size and then put them back together. However, as you can kind of see in this feature over here, to some extent, it actually kind of cut across the feature. So while the automated subdivision can be helpful as far as not having to go through and pick different pieces, you may end up having to pay for it a little bit on the back end. So that's just something you'll have to kind of choose what use case is best for your own project, but it's good to be aware of one way or another. So this was just a quick mock-up, basically kind of taking those stone features and put over a DEM, a digital elevation model here. So this kind of topography is the correct topography for the area. Put in some quick kind of vegetation assets to give it here a little bit, but this kind of shows some of the benefits and some of the things that could be done with these models. So at the OU site itself, again, while you're able to go out and see the site, there's a rope around the outside and you're not able to enter inside. However, this site itself is a large kind of stone circle feature that's actually made up of many different smaller features together. And so while I had the privilege to be able to go in and scan it and kind of see these things up close, it's something that a general population wouldn't necessarily be able to do. However, again, with the 3D model and set up kind of in this format, it allows people to kind of go beyond and interact and experience the site in a different way. Shrinking kind of down to a smaller scale, I'll call this mid-size scans. And for examples, I'll talk about some of the pit house scans that I did, as well as looking at, again, the Sugisawa and Suwahara site, but kind of on an excavation site basis itself. At this scale, you start to kind of get some diminished returns when it comes to dealing with drones. And in a lot of cases, a camera pole can kind of cover what you need. It's a little bit faster to use, and you have a little bit more control to cover different areas. Additionally, some additional lighting issues of scale and resolution start to become kind of more important as you get down to these smaller scales. And in the case of dealing with the pit houses, as you get to smaller areas, kind of access can start to become a little bit constrained, and freedom of movement can start to get restricted a bit. Again, just kind of going broadly talking about the research topic in general, the pit house project was basically examining the different styles of pit houses. Basically, there's a number of different kind of styles and layouts that we find in the archaeological record during the Jomon period. And there's also ethnographic evidence that connects basically construction costs and energy costs related to building structures and dwellings and mobility. So the idea was to try to quantify differences in material and energy costs with different pit house styles, and to see if maybe shifts in pit house styles could have been tied to shifts in mobility or sedentism. To kind of get a little bit of a baseline, now reconstructions that we have today, we know basically what was in the ground, but what's up above the ground is a matter of interpretation. And as you can see here, there's a number of different styles and interpretations there. However, looking at a wide variety of different interpretations gives us a little bit of a baseline to work with here. And again, the focus with a lot of this was looking specifically at the framing and support structures of these pit houses. Data capture issues. First of all, as far as in trying to tackle this project, there's a limited number of pit houses at sites kind of spread throughout the country. Most of these sites are open to the public, so the time allowed and available to scan them is limited. You don't want to be blocking the public out from being able to see a site that they came to see. Additionally, these are complex structures. There's a large number of inner supports, and instead of kind of a squared structure, which may be a little bit easier to model by hand, these are a little bit more complex. So scanning, 3D scanning and photogrammetry was a bit of a better fit as far as to work with this. Again, the goal with this was to try to capture as much as possible, as quickly as possible within one visit at each site. I talked about kind of constrained environments. Some of these spaces were fairly small to work around with. And in addition to the camera, because it was dark inside, I had a powerful ring light as well as a big battery strapped to my back. So it was a little bit hard to move around. The inner portions had some obstructed views due to some of the inner pillars. I talked about some of the lighting was quite dark inside. The angled surfaces could also cause some additional problems because you're dealing with issues of depth of field. With photogrammetry, you're wanting to try to keep as much within the camera frame as possible in focus. And when you're kind of dealing with these longer distances, you start to get areas that are out of focus. And additionally, this is kind of more of a after the fact issue, but trying to align the models could be difficult, especially the outer portions and the inner portions. Basically, in order to get the two pieces connected, you need to have some shared points that can be viewed from outside of the structure as well as from inside of the structure. In which case, as you can kind of see in this picture here, some targets or scale bars became really beneficial there. Those could be basically automatically recognized with the photogrammetry program, and more often than not, I was able to get some good alignments after I learned my lessons with early scans. Here are just a couple examples. This is just the point cloud rendering from the Umenoki site in Yamanashi. And again, talking about the data that you'll be dealing with in scans of this scale. These were typically running over 1,000 images per structure. If I had more time, probably more images would have been better. The camera I was using was a Sony a7R IV, which has a 61 megapixel sensor. You get some really large file sizes, a lot of resolution, but you do end up having to pay for it with storage. Even shrinking these down to 100% quality JPEG images still brought it down to around 20 megabytes per image. And considering that quite often for these scans, you'll be dealing with two image sets, one that's basically post-processed and optimized to pull out those feature points and reconstruct the geometry, as well as kind of a more color accurate texture layer. Again, file sizes start to build up. Early on, I played around with TIFF, which is basically a lossless format, which is wonderful in some situations. However, when you're dealing with over 1,000 images at 300 megabytes a piece, it's more than what's needed. And again, if we're trying to focus on the goal of the project, it ends up more of a burden in that instance. An early test case with the project was the Yamashiro, this little pit house mock-up at the Yamashiro Regional Museum in southern Kyoto. Again, this is about half of the images that I used later on, but I was trying to test out ideas of, again, how to focus on those inner structural members and manage those. Even though this is kind of a smaller model in comparison, it was still quite large that a lot of programs at the time, like Blender, couldn't handle these type of poly counts. So I had to switch over to ZBrush, which does a bit better with it. With a focus on kind of these interior structures, as you can kind of see around in this image, again, the outer section has a lot of geometry that while is interesting, isn't as important for my research purposes. So I kind of looked around at different ways to remove any unnecessary geometry or parts of the model as possible. You can see kind of I pulled away digitally some of the thatching from the outside, kind of going around later on and pulling in between sections, tried to pull away thatching from there, pulling off the bottom section of the floor. Again, we cut off 100 million or so, but there was still a lot of data to be working with. As part of this kind of wrangling, I tried separating out these structural members from the rest of the scan to selectively decimate, basically try to keep higher resolution of the pieces I'm interested in, meanwhile kind of decimating or simplifying sections that aren't as important, which worked to an extent, but it took a lot of time, and I came across a much better approach when I'm just looking at measurements. And that is these cross sections. Within Reality Capture, there's a cross section tool, so this can be done fairly quickly. You can specify how often it makes these cuts, and you can selectively go around and kind of pick representative cuts to measure later on. So you can see as far as we can kind of take horizontal slices or vertical slices. And these can be exported individually as DXF files, which in this case here, I imported into Blender, turned them into a mesh, which then could be measured kind of vertex to vertex across the way. Again, kind of you see an example of one of the cross sections here. Additionally, these slices allow you to kind of get some DEM type models to be able to do some slope analyses on the structures as well. Kind of one of the benefits, again, with this approach of kind of 3D scanning and oftentimes photogrammetry specifically, is some of the flexibility that's available to you. Because you're taking thousands of photographs, you've got a lot of reference images to work from. Additionally, after the fact, if there were certain measurements that you planned on taking and then afterwards you decided, there's a better way to do this or a different way to do this. If you have the 3D model, you're able to go after the fact and kind of reevaluate this data. Additionally, you have dual use in which basically at the same time that you're capturing data for research purposes, with a bit of work, you're also able to turn that over for kind of public outreach as well. Going down even smaller as far as kind of an artifact scale. At this point in time, you have some more, what's the right term here? The portability of the objects, of course, has increased here. So I'm able to manipulate objects instead of kind of manipulating myself and the camera around in order to scan it. At this point, you're able to kind of shoot on turntables or using light boxes. You have more control if you're in a studio type environment to attempt different kind of lighting approaches, whether it's constant lighting or using flashes or strobes. I particularly for a lot of the scanning leaned into what's referred to kind of as scanning the void using cross polarization, which I'll get into here in a little bit. Again, going back to kind of images and file sizes, just a little bit of a breakdown with some examples. If you're dealing with kind of simple, smaller shapes, I was working for a lot of these pottery sherds at about 100 images a piece. So each image ring on the turntable is about 20 images each with about 5 different elevations. You can go lower, but sometimes you run into issues with alignment, in which case then for the capturing stage, you're saving time, but when it comes to sitting behind the computer and making the models, you're causing yourself some more headache. So I found 100 images allowed things to go pretty smoothly. For kind of mid-size and more complex shapes, again, 200, 600, it all depends on the object you're working with. For example, like I said, this sherd here is about 100 images. This section of a jomon pot, close to 300. This kind of intricate handle of a jomon pot was getting 550, getting close to 600 images. And this yayoi tsubo, this jar, was around 315. For this handle, because there's a lot of kind of self-occluding areas of this piece, again, you have to be able to see a section in order to record it. So you really have to kind of move around quite a bit in order to capture every bit of that model. And specifically for the yayoi jar here, the neck was quite narrow, but I still had enough angle to scan most of the inside. So again, it took a lot of images, but the inside of that model turned out fairly well. Kind of this combination of outreach and research in terms of the artifacts here. We'll do kind of the case study of some of the examples I showed before at the Tsuzuru Ozaki Lakebed site in Shiga Prefecture. It's in the northern end of Lake Biwa. You can see around here. For about 100 years, people have been bringing up pottery from this area in nets. And a lot of it is quite intact. In 1973, there's an underwater investigation using divers where they went around in some of the shallower areas. And in 2010, Ritsumeikan University with Kenichi Yano had kind of started a number of investigations in the deeper waters using robotic submersibles. So there's kind of one of the submersibles that was used. You can see examples of some of the images that were taken of pottery down in the lake bed. Now these are still left in situ, they weren't brought back up. However, this is an example of one that was brought up. I'll point out in a second here this kind of adhesion. We'll talk a little bit more about that in a second. And again, kind of these are some of the sites where pottery was found during some of those robotic surveys. For some of the Tsuruozaki pottery, there was 169, about 170 pots collected up to this point, many of which were intact. They date back to the initial Jomon period, 7,000 years or so is kind of the earliest example up to the 18th century. There's a number of different hypotheses or explanations regarding why so much pottery was found in this area, why so much of it was intact. Some of the thoughts are maybe that there were landslides in this area. There's a large earthquake in 1185 that maybe a landslide was associated with, so these were on land and brought down. You'd think that maybe they would be broken in that process, but we don't know. Possibly, again, pottery falling out from boats during transport, or possibly there is a ritual aspect to at least some of these instances. Like I said, large number of intact pots. This pottery, when it's in this area here, it's largely unmoving once it's kind of settled within the lake bed. And the area where the kind of soil from the lake and the water meets, the pottery has built up these iron deposits. The soil around the area is very rich in iron, and you start to see these adhesions. And so the project, from the goal of this project was basically we were looking to do a thorough examination of some of this pottery. The pottery was measured and drawn by hand. Color information was recorded, and on my part, I created 3D models using photogrammetry in order to kind of get a better understanding of the pottery, specifically these iron deposits, which kind of allow you to view the lake bed orientation of the way that these pots were sitting at the bottom of Lake Biwa, and then at the end share these completed models online. For equipment, again, the same camera that I used for the pit house was used for this, Sony A7R4. Included a circular polarizing filter, which we talked about, that void scanning technique. The same flash as the pit house as well. It's a Godox 80-1200 with a ring flash. It's quite powerful. Overkill probably for these instances, but again, you can dial it down and it worked well. I had to custom design and 3D print a filter mount on it, but that worked pretty well. Used a couple different automated turntables depending on the pottery that we were dealing with. Black background that you can see, a couple tripods, and actually the camera later on was mounted to a rolling C stand, which made adjustments much faster and less finicky. As you can see from the image, maybe you can get the idea of where the void term comes in here. There's a CG artist, Eric Christensen, down in New Zealand, that does a lot of photogrammetry work with his company ScanSpace, that has shared a lot of information on this online. This process is basically relying on cross-polarized light. Basically, you've got a polarized filter in one direction on the light, and in a perpendicular orientation in the other way, you have the filter aligned on the camera, and it's basically blocking out a lot of the extra kind of shine, specular data off of these objects. So a normal image here, I think actually, you can kind of see the background around here. However, with some lighting adjustments, you're basically doing some in-camera masking. So you're saving yourself some time in processing by approaching it this way. At the end, kind of model ranges between 35, 125 million. Initially, when this project started, Reality Capture, the photogrammetry program I used, couldn't handle anything over 40 million polygons as far as in mesh. So these larger models needed to be decimated or simplified into something that could be managed within that program. For sharing the models online, however, Sketchfab recommended keeping poly counts under 2 million for desktop users and under 500K for mobile users. So the research purposes and the research level models and the kind of public models need to be processed differently in order to be able to kind of reuse the model in multiple ways. You can kind of see some of that decimation here going from the 40 million, 20 million, 10. 1, again, you can kind of see that we're smoothing out even more so to 625. However, again, when you start to apply textures to these, it's really hard to pick up some of those details. These were some of the earlier scans. These, using the cross polarization, can have a tendency to get a little bit of a orange cast, as you can see to a lot of these. This was adjusted fixed later on here, which you can see in a second, kind of some more natural coloring. Again, this is a lower resolution from Sketchfab, but kind of much more true to life. Again, these, for research purposes, the 3D models were used to kind of really look at these iron deposits on these different pieces of pottery. Some of the issues in trying to measure these is Jomon pottery is not created on a wheel. It's basically hand coiled. So there's differences in thicknesses at different areas. And so if you're measuring basically from the inside to outside, if the wall thickness isn't consistent throughout, it'll throw off some of those measurements. Again, as you can also see, kind of these are complex shapes. So trying to pick what would be a representative point can be difficult. And on some of them, the iron deposits were actually quite fragile, so you don't want to mess around with them too much. To kind of handle some of that, I tried to basically remove some of these deposits digitally early on. Basically kind of creating a copy of the model and cutting and smoothing out the section around. You can kind of see where the deposit is over here and kind of where that's cut to keep along with the line of the pottery. Then basically use that smooth pottery as a tool to cut away the deposit itself. And then you just kind of have the remaining iron deposit there for the most part, which is all isolated and ready to be measured. Another approach to kind of looking at this is dealing with color ramping. In this case, we are just measuring basically the inner surface to the outer surface. You can adjust the scale of how it's color ramped in order to identify the changes in thickness to make it a little bit more visible. Additional benefit of this is basically these distance measurements are saved on a per vertex basis. So while we have a rough guide with the color here, you could actually go look into specific vertices and kind of see what these measures are. And again, the benefit of working with the model as opposed to the object itself is we're able to kind of conduct multiple measures all over the place without possibly damaging the pottery later on. For the outreach section, again, compared to a 2D image, there is much greater degree of possible interaction with a 3D model. You have a range of movement, freedom of movement that you can use, just as if you were holding the object itself. If there's any specific interesting features, you can kind of zoom in and focus on that. With 3D models, again, by taking the texture layers away, if you really wanted to see geometry, you could do that as well. Additionally, since you have these assets, you can also try to kind of visualize them in context. So this is just a quick lake bed 3D scene that I had mocked up and basically aligned this pot where the deposits on that pottery was here. So we can kind of get a visualization of what this particular pot may have looked like sitting at the bottom of Lake Biwa for hundreds of years. Additionally, so the materials, the Tsuzurosaki, at least the ones that we had scanned, are maintained and managed at the Lakebed Historic Remains Museum. It's a small museum that's kind of run mostly by the local community. Access to it is kind of limited. It's not necessarily near any major train stations, other things like that. And so by being able to create 3D models of these, share these online, you're able to kind of connect to more people. And by making sure that you are linking back, giving credit, and trying to kind of direct viewers of the models to the museum, if they're interested in seeing them in person, they have the resources to be able to do that. Going a little bit smaller here. So again, dealing same with the Sugisawa and Suwahara sites. The turntable scans that I had done before worked well. They were semi-automated, but there was still room to improve this approach here. There was a lot of intervention required when doing these turntable scans. While the turntable is turning around automatically and pictures are being taken automatically, adjusting the elevation of the camera, moving it in and out as far as to make sure that the exposure between scans is similar, requires a lot of babysitting. Each ring would go around. It moved fairly quickly, but it wasn't so slow that you could go off and do something else, and it wasn't so fast that you could completely focus. You'd kind of sit around for a little bit, wait for it to do its thing, and then go back. For a limited number of scans, that's not a problem. However, when you start to scale that up to larger numbers, kind of more objects, that becomes a problem. At Sugisawa, there were some ongoing art and archaeology projects where they were taking, after the excavation season was done, they were taking the artifacts and trying to display them in their kind of positional context where they would be within the site. Initially, I believe they were suspended from the ceiling. Another display came where small rods were supporting the pieces from underneath. But we had decided for this kind of new excavation to try to do this approach digitally. In order to do this, we basically kind of combined that medium scale scanning where we were doing multiple scans of the excavation site itself, and then combining that with individual artifact and small sherd scans as well. There were 15 scans of the excavation for Sugisawa, and there were over 180 sherds to scan individually. Using that prior turntable approach, scans, even with a little bit of help, would take about 20 minutes apiece. Do the math there, that's many hours of scanning. We had gone for some of the smaller pieces, tried to at least scan 2 at a time, but that still required some additional processing after the fact. So a bit of a wash, I think, time-wise. Save some on data, but you're paying for it with time. Again, kind of here you can see some of the individual scans of Sugisawa as they're positioned and kind of how they would be layered and aligned on top of each other. Here's a view of some of those 3D printed targets I was talking about. This is kind of the burial pot itself within the excavation. In order to keep track of things, what we would do with each excavation scan, we would do a scan, and then before we would take out the individual pieces to get to lower levels, we would kind of record as we took them out on some printouts to make sure that they could be aligned later on digitally. As you can kind of see over here, the end result was really pleased with. Not only kind of visually was it appealing, it allowed you to kind of examine the pieces and the depositional context of the pottery in a way that would be really difficult to do otherwise. Additionally, we've done some work as far as trying to refit, to try and piece the pottery together and having a reference scan to be able to see exactly what piece was next to which piece was really beneficial. At the Suwahara site, I ended up running into something similar where there was a central belt feature within one of the pit houses that had a lot of this ornate Suemon style pottery that we wanted to try and get an idea of, again, the depositional process of it. So since we had started with Sugisawa before, applied some of the same approaches with Suwahara, being a little bit wiser. Target placement, in order to try and align the scans, kind of more targets were placed both outside and inside the excavation areas, just kind of out of the way. Total station was used to kind of accurately map the targets around. Imaging improvements, the same camera was used throughout all scans. We made sure that coverage of each of the scans was sufficient, as well as making sure to really cover those extra targets around on the outside. And as you can see, rather than dealing with printouts, we found that just adding some tags and taking some reference images really helped with that collection process. And kind of not necessarily more importantly, but a bigger improvement was with a new automated scanner that I had put together here. You can kind of see it in a high-speed version here below. There's flashes going on in between. The benefit of this is basically it reduced the needed interaction. So we didn't need to sit around and really babysit it as much. For this kind of setup and build, it was much cheaper than like a structured light scanner that you may buy. And because we're dealing with photogrammetry and high resolution sensors, the texture and color quality is better. Speed, you are limited to kind of using a single camera in this instance, and working too quickly can overheat the lights, but it is something scalable. Basically, you would set it in, hit start, and you would have 10 minutes or so to kind of do some work. When it finished, flip it over and go again. And so in a scalable manner, you could have several of these going at the same time and work fairly efficiently. Here's just a few images of kind of the progress of that project. Again, all of the excavation scans are processed, the artifact scans are processed, and we're now just in a position where we're trying to match those up like we did with Sugisawa. So I've talked about storage quite a bit here, and the number of images and the kind of data that you're maybe encountering in doing these kind of projects. And kind of data storage and reuse, if we're backing up and looking at an initial planning stage, is something really important to focus on. Specifically looking at kind of what data you want to save, what data you may want to be sharing from a project. For both of those, are you just keeping or sharing the models themselves? What are you doing about raw data or intermediate data as far as while you're processing things? Do you go and try to share all data all together here and just work out an infrastructure for those storage needs, as well as kind of who this data is for? The data that researchers may need could be different from the data that the general public needs. There also may be some issues with data sensitivity, which I'll talk about in just a second, that you need to be aware of. Again, just talking about some of those intermediate or extra files that you may be dealing with. Specifically with me, you're dealing with project files, again, whether you're using reality capture or Metashape, ZBrush files or Blender files, different OBJ model files at different resolutions or different processing or formatting that you use, the different texturing files, again, like diffuse, normal, specular roughness, ambient occlusion, other things like that. Maybe MeshLab or Cloud Compare files, as well as additional kind of outputs, images or renders. Again, this really starts to build up when you're in the middle of it. And it can become overwhelming if you're not prepared for it, which gets back to looking at those kind of desired data outputs as far as how you're wanting to use this data, how you want it to be processed or analyzed, how you're going to share it. You'll need to hopefully make a plan. Things don't always go according to plan, but a plan helps. Focus on kind of what is needed and try to trim out unnecessary steps whenever possible. When you're setting up your initial workflow, this can be kind of tricky. I would highly recommend, especially at the beginning of this workflow creation, to save your intermediate steps, because having to reprocess models over and over can waste a lot of time. If you're dealing with a lot of different scans and trying to work them through, you may want to consider a sequential or hybrid workflow if your data needs are too heavy. Again, as you process these files, data kind of builds up and up and up. So instead of doing that, if you kind of process files from start to finish, work them through the pipeline, and then kind of zip them up, package them up, kind of put them in storage and go on to the next, it makes some of these data issues a little bit easier to manage. For saving files, I would suggest not kind of overdoing it. I recommend keeping raw files because that's something that you can always go back to. For intermediate, that'll all just kind of depend on what your project needs are. Talking about data management in general, I may be preaching to the choir here, but if not, you talk about kind of a fair data approach, looking at findable, making sure your data is findable, accessible, interoperable, and reusable. For findable, trying to make sure that you have persistent identifiers connected to this data, typically through DOIs, that you have kind of rich metadata kind of describing these files, and that the data and metadata are indexed and searchable. Accessibility, basically making sure that the protocols, the ways to access this data are based on an open, free, universally implementable protocol. Quite often, again, these are often web-based using HTTPS, something like that. Interoperable, making sure that basically the data and metadata use formal, accessible, shared, broadly applicable language for knowledge representation. Ideally, you'd want kind of shared descriptive vocabulary sets, but this is not always possible. You may be dealing with different languages. You may be dealing with different cultures in which there's not a comparable object to go across with that. You just have to kind of do your best. Again, reusable, again, making sure that you have the licenses for the models kind of clearly stated. Again, that the metadata is connected to this data, and that metadata and data are standardized and consistent. Dealing specifically with archaeology and kind of with an anthropological background that I have, there's also a separate approach to data management and the ethics of that, called the care principles. This is looking quite often dealing with indigenous populations, and you're looking for collective benefit, authority to control, responsibility, and ethics. So dealing with collective benefit, you want to make sure that the data ecosystems are designed and function in ways that enable the indigenous populations to derive benefit from that data so that it's not an extractive process. The authority to control, to make sure that indigenous people's rights and interests in their data is recognized, and that their authority to control the data is empowered. So again, kind of acknowledging that this is not the data of the research, but the data of the people, and that they have the ability to kind of choose how that data is used. Responsibility, making sure that people working with indigenous data have the responsibility to share how the data is used to support the indigenous people, self-determination, collective benefits, and that ethics, that their rights and well-beings of the indigenous people are the primary concerns at all stages of the data lifecycle across the data ecosystem. Actually, sometimes these approaches conflict in some ways, in which it's not always a clear-cut approach. I would say, as much as we want to make sure that data is open and shared around, I think that the care principles kind of should take priority, basically, that you're not harming or taking advantage of these people, that you're working together, hopefully with and supporting each other. We're kind of wrapping up here towards the end. Part of our R-GIRO project has dealt with kind of the issue of resilience. And one of the aspects I've looked at in dealing with these different 3D projects is the concept of kind of digital resilience. Again, making sure that files are properly managed, that you have a good backup strategy, again, that data is accessible, and that basically the data storage and maintenance is planned in, hopefully from the beginning, for a long period of time. Again, basic backup stuff as far as 3 copies of working version on-site backup and an off-site backup is kind of a standard process. However, again, dealing with the amount of files and kind of how heavy this data is, you're tripling up on the amount of data that you're having to manage with some of these projects. And kind of just some examples, just those artifact folders, many of them are 100 gigabytes or so, pit houses getting close to terabytes, stone circles, easily over a terabyte. I'd reached out to some kind of professionals that do VFX for games and movies to ask kind of how they manage this. For a lot of those groups and companies, they may store copies for 6 months, at which point they just trash it. It's up to the client. From an academic context, just trashing data is not really an ethical way to go about it. So really, as we kind of move forward, including more of these kind of 3D scanning photogrammetry projects, we kind of need some more institutional support for long-term storage and maintenance. There's different ways to go about this, as far as you can kind of do it yourself or within your own institution, in which case costs are including hardware, again, purchases of drives, replacements of those drives, and management, somebody to make sure that things are running properly. Meanwhile, you could go a cloud storage route, which may give you more stability or instability depending on the company, but you also have to factor in possible cost increases over time within your budgets. Finishing up here, this is the last slide. Photogrammetry as a tool has become more accessible than ever. It provides a lot of increased opportunities, but again, kind of dealing with project management and data management, it's increasing storage and preservation burdens as well. I think we need some more standardized approaches to kind of handling photogrammetry data, some minimum standards for kind of what data should be stored and maintained. And ideally, eventually working towards kind of a national or interinstitutional repository. In Europe, there's a number of different initiatives where they're kind of working on this at a national scale. An example, again, for institutional approach is MorphoSource, where you're dealing with multiple colleges kind of sharing the burden across that way. Again, it's exciting stuff. There's a lot of opportunities there. A bit of planning early on will save you a lot of headaches that I had to go through as I've done my research. And I wish you all the best. Thanks very much.
All right, thank you so much. That was really interesting. I don't know, as someone who does not work in 3D models or in photogrammetry, there's a lot of basics that I learned and a lot of very basic questions that I have, but also these what's the word? These ideals of these guidelines of fair and care, which I had not heard of before, and those are really good, simple models, or very simple what's the word? Easy abbreviations to remember. So I really appreciate that. All right, we have plenty of time left for Q&A. So if anyone has any questions, please feel free to raise your hand or use the chat box. どなたか質問があれば、ぜひ、手を挙げてください。Oh, okay. In the meantime, while we're waiting for that, I'll take a glance at my own questions. Let's see. Okay, so this is going to be a really basic question.
Sure.
And you might have said so at the very beginning of the presentation, and maybe I sort of missed it, but just how, I guess I can imagine using targets, how software could automatically pick up those points and sort of do it. But I don't know if you could just talk a little bit more, or maybe go back to that slide about how you combine all these images, to a matched point that really aligns everything well.
Sure. Well, maybe I should go back to.
Because I'm thinking of, especially if you have like a handheld camera and a drone, those are very different scales, right? So, but the software just sort of aligns it.
So let's see here. If I'm rescaling, let's see how quickly I can jump back so many slides. No, not at all. Basically, the targets, kind of the 3D printed targets, are machine readable. They'll either be kind of circular targets, which maybe people are more familiar with. You also have kind of April tags, which look like a QR code of sorts. Those are basically machine readable. You're able to automatically pick those up in a scan. Kind of one of the benefits is, for instance, actually here, I'll go back. So for these scale bars here, right? So actually we have the two examples, right? So these are 12-bit circular targets, and these are 36H11 April tags. Basically, there are center points that the computer can automatically kind of pick up and calculate. And the benefit of having a scale bar is basically I'm able to say after the fact that the center point of this target and the center point of this target are 10 centimeters apart, and I can automatically scale a model. However, kind of these are set up just for individual points. For the actual model itself, let me get this out of the way here. This is kind of a rough image, but hopefully you can kind of get the idea. These kind of P1, P2, P3, P4, P5, we'd consider kind of feature points. And feature points in an image, in fact, if we were just looking at the slide itself, you're looking at patterns quite often of high contrast. So the end of photogrammetry, any of these sharp lines or edges or this and that, are areas that on multiple images you could identify, this is the same point. And so across multiple images, so it shows kind of in this example, P1 here, that the position, depending on where you are at within an area, the position within your camera frame of that feature point will move, will be different. And by looking at all of these different feature points and where they are in each of these images, you're able to first align, basically say, okay, this image has these points, this aligns this way, and you're able to triangulate where those points are in 3D space. The concept of photogrammetry is actually quite old. I think first came around 1800s as far as the basic idea of being able to plot this out. However, well, right, and so, but basically with modern computers now we have kind of the power to very quickly go through and do these calculations to the point now in which, again, even kind of basic computers, you're able to do that here.
Very basic question, but I appreciate it.
No, I mean, it's tricky in some ways, so.
Yeah. So I guess while we're still waiting for other people to have questions, I'm going to ask another very basic question, which is, and I suspect I know the answer already, but nevertheless, if you have objects in the, okay. Okay, I'll skip and I'll let Yano Sensei go. So, Yano Sensei, dozo onegai shimasu.
Can you hear me?
Yes.
Okay, great. And Kosi, your first name is Kosi, right?
Corey, yes.
Okay. Thank you very much for introducing the number of case of photometrography technology applied to R-GIRO site on various scales. So, my background is a GIS and GIS science, so I'm very familiar with photometrography as well. I guess our Art Research Center, so far, we have many kind of 3D model using another technology, for example, LiDAR data. And recently, we use photogrammetry and something. So my first question is, have you ever some collaborate with Ritsumeikan University researcher from the information engineering, science and engineering? So this is because we have many experts of 3D modeling researchers in informatics and engineering and in BRCO campus. So they have the very nice technologies. For example, using the visualizing the point cloud data and something. So do you have any collaborate with some colleague colleague in information science and engineering. For example, Professor Satoshi Tanaka sensei and something.
Actually, just recently, I was in contact with them here. Up until this point, again, outside of the archaeology department, I really hadn't. However, kind of as I've continued to do more of this 3D work and have been at the university longer, I've been trying to kind of reach out around to different departments and people. And actually, through the CA Australasia chapter, I was introduced to him basically from someone outside the university, but back into Ritsumeikan. And yeah, we had corresponded a little bit. I think there's a lot of good opportunities to try to work together with things. I think research interests are overlapping very much.
Yes, and we're very happy to have your technology for our research at the Research Center. And actually, we use many photogrammetry and LiDAR data for a little bit large scale. In your case, it's a medium scale. In a house, inside and outside of house, something. So actually, we use we compare with the methodologies between photogrammetry and LiDAR data. So, and the middle scale, for example, our target is Kyomachi housing, and Japanese traditional wooden house. We like to restore the inside and the outside of Kyomachi. So our result of comparing the photogrammetry is not good for creating the 3D model inside. So we prefer use LiDAR data, and especially Matterport. Do you know Matterport 3D Pro?
Sure.
We use that one. So this is because photogrammetry is some lack of the part of the space, and quite difficult to restoring the 3D model. In your case, do you have any comparing the methodology between the photogrammetry and the LiDAR data and something?
I think very much, I mentioned a little bit, because of course there's all different sort of scanning tools you can get into as far as different tools for different jobs. Again, LiDAR is a fantastic technology, again, dealing with large areas, large scans, other things like that. It works very well. As you're aware, however, LiDAR units can be quite expensive.
Right.
Additionally, so accessibility can be an issue in some cases. Additionally, specifically within the pit houses that I was dealing with, again, we're dealing with kind of cramped areas, and I also needed to be able to get up and around in some obscured areas that would have been a little bit tricky to do with LiDAR. A smaller unit like maybe the BOK 360 is kind of designed for some of that, but again, dealing with kind of budget and time, I had gone through kind of the photogrammetry route. However, considering the amount of work that it took to try and do all those images, I think going with a LiDAR unit would have been a much more comfortable experience.
Oh, yeah, thank you. And and actually at the research center, now we have many 3D objects, but tangible cultural assets. So I guess Akama sensei and some my colleagues would like to have the 3D model of the artifacts using the photogrammetry. So we would like to have some collaborate with you. Thank you.
Fantastic, thank you.
All right, thank you so much, Yano-sensei. If anyone else has any questions, please feel free. There's still a good amount of time left.
I'm not sure.
Yes.
Tanaka sensei and Kim Lee sensei not joined. I'm not sure.
Yeah, they're not here today.
Okay, right.
But,
I'm sorry.
yeah. Yeah, but it would be really good to, I mean, I don't know. I hope that you can have some good collaborations, I think.
And one more thing, if no other comment. And we have at Research Center, we have some staff for especially for metaverse. You showed some a video about the metaverse space. So as well, we would like to have some further collaborate with you for metaverse space, I hope. And for example, Yamauchi sensei, if he joined it.
I think that would be fun. I actually, for the Sugisawa site, I didn't really have time to get into it. But in order to position all of these sherds, kind of align them with the 3D scans, ran into some difficulties with some of that. One of the ideas is there's some different add-ons where you can kind of pick three of the same points on different models, which will automatically align and scale them together. However, at the time, kind of dealing with the number of models and kind of overall the number of polygons I was working with, I had to kind of work at lower resolutions. And the geometry, the actual vertex points of those models and what you would see on the texture didn't always align. So that didn't work very well. And it got to be a little bit frustrating, the idea of something that, you know, is very natural to be able to just kind of place something in position, that I was having so much trouble with. So I actually switched and used a VR headset and handles and actually positioned a lot of those pieces kind of in VR space. It was much more natural way to work, and was actually really interesting kind of within the 3D space. Not only was I working with the models, but I could go and pull up reference images and have those off to the side, have the software interface as well. So I think there's a lot of really interesting potential for different ways to kind of work with these materials kind of in a VR space. So yeah.
That's true. Yeah. That's it. Right.
Thank you, Professor Yano. That's really interesting, the ability to sort of manipulate objects within VR space for your own work, for your own research, you know, applications, but then also I would imagine that it wouldn't be, well, I shouldn't say whether it's difficult or not, I don't know anything about the technology, but I would imagine conceptually you could then move that over to some kind of educational, you know, bring people into a VR space and then manipulate objects virtually within that space, right?
They've actually there have been some pilots run with some virtual field schools for archaeologists, basically ways they set up kind of a VR environment where you would kind of do some of the tasks that would normally be involved in excavation within a VR space. Kind of field schools quite often internationally can be quite expensive as far as traveling off in order to have these experiences. So accessibility, which I'm a really big proponent of, I think there's some good opportunities involved in some of that. The VR technology can be a little bit clunky. I think it's getting better. I ran into issues when I was doing that. The headset I had didn't have good pass-through. So basically headset was on and there wasn't any way to kind of quickly view what was outside. So I'm constantly having to kind of flip up and down. Meanwhile, kind of newer headsets have pass-through. So you're kind of getting a bit more of a AR type interaction with these things, which would have made the process much more comfortable. I mean, I'm kind of still maybe a little bit silly around in the office with the big VR headset on, but at least I could see when people are coming in and out instead of just hearing some noises in the corner.
Sure. Well, anyway, I'm excited for, hopefully you can talk to some of our colleagues here at the ARC, and I think there's potential for a lot of good collaborations there. If anyone else has questions, please feel free. どなたか質問があれば、ぜひ。If not, yeah.
I flip around and ask actually Professor Yano a question maybe, if you're there, Professor Yano.
Yeah.
I'm curious because I talked about kind of constrained space and Mattia are famously kind of narrow. I'm a little curious because a lot of LiDAR scanners have distance limitations as far as making it kind of minimum distance from the scanner. Kind of how you were able to deal with some of that. Were you basically getting bad data up kind of nearby and just relying on kind of the more distant data, or how did you manage that?
And actually, we use Matterport Pro 3 and something. 360 degree camera and LiDAR. So automatically it created all direction. So every 2 meter, we set a LiDAR port, a Matterport Pro. So, and actually every 2 meter interval should be fine for all rooms of geometry. So we use that. And at the inside of house level. So, and sometimes we use, MMS, mobile mapping system on the car and on the street. As well, we use MMS data. That is a point cloud as well, and the color RGB point data. And resolution probably, I guess, few centimeter or much more less, I think. Actually, our project, we use LiDAR data 2002 from the Cessna airplane for measuring the height of buildings. So, and but meta shape and something the photogrammetry technique within the maybe 5 years, much more easy to create a 3D model. So, but now is we convert to photogrammetry 3D model to point cloud, and as well as the polygon. So it's quite high-speed computer we need, but now we can do that, I think.
Thank you. It's interesting. I've spoken to, again, kind of dealing outside of academia, kind of dealing with more of the movie VFX. Quite often, a lot of times, again, these approaches are combined. So kind of using that LiDAR data, which really gives you kind of some good discrete geometry, and then using photogrammetry in order to kind of get better textures and kind of basically wallpaper the model with kind of higher resolution images. So,
yes. And actually, recently, the hybrid methods, some major company recently use it. Quite nice, but quite expensive. That's true.
Yes. Yes, definitely.
Well, it's all right. I think we'll go back to my basic questions because I'm
please.
Curious. Although that is very interesting also to learn about, what kind of, given technology limitations, how the LiDAR and the photogrammetry be used together. I think I've seen some examples of that in demonstrations here at the ARC, so that's exciting. But going back, I'm just curious because I don't know. Going back to the question about targets, right? I suppose it just depends on the objects that are actually in your scan, right? Buildings or stones or whatever. If the stones are sort of recognizable enough, can you use those as targets or?
Absolutely. Yeah. So again, if you're
the shapes have to be really discrete.
you have to kind of have some clear feature points. And one of the problems, again, kind of dealing with OU is you're dealing with high resolution pictures kind of down on the ground. And then the drone was using, I think it's a 20 megapixel sensor. So not bad, but not the same. And you're also at a greater distance. So being able to kind of pick out basically some very fine details maybe that I could pick out from the ground wouldn't be visible from the drone. So you'd have to find something that was covered between the two image sets that connect them together. One of the other benefits of targets, if you're not just looking at alignment, if you're talking about georeferencing, so being able to make sure that everything is scaled and in the same position kind of as they are in real life, by having targets and kind of accurate measures, you're able to kind of scale that data and arrange that data to be able to kind of put it within a more GIS context. Yeah, ideally, I mean, there are cases in which with photogrammetry, you can't see right now here, but we've got a very gray, kind of flat gray table here, and there's not many feature points or anything like that. So certain materials that don't have a lot of features. In fact, talking about scanning within homes, you know, if you had a white wall without any kind of feature points, photogrammetry would have a very hard time kind of aligning that and picking that up. For smaller objects, again, if you have something featureless, sometimes they have certain scanning sprays or other things you can do to kind of get a temporary feature that can be used, which then kind of sublimate, they evaporate on their own afterwards. Depending on the type of object, though, some people would prefer not to have anything sprayed on any kind of precious objects. So that's not always an opportunity, but kind of for more normal, less precious objects, that's a possible approach to use.
As it happens, just by chance, I was talking the other day to a friend who works in robotics. And I don't know very much about his job. I don't know very much of the details of what he does, but he was talking about spraying objects to make them less reflective so that a LiDAR scan or a photograph, I guess, I'm not sure about photogrammetry, but so that a LiDAR scan or other things would pick up the shape of the object better. But then you can't use those sprays on museum objects, probably most typically. So, yeah. Okay, we're almost out of time, but Yano Sensei has shared a link to, okay. Let me,
Metapart, the scan here.
yes. So, right, so this is the Nagaike Judaku.
You can find the circle. Circle is measuring the point, right?
So this is a Machiya downtown right next to Funahoko.
Yeah, please join the Gion Festival next week. Next week. Please come.
Here's the Funahoko itself.
I've seen, because you've done the LiDAR scans of them in previous projects, right?
Yeah, it's a writer. But anyway.
Yeah, thank you for sharing this.
There's her scanner in the mirror.
Right.
Surprise.
Yes, this is
in case anyone's curious what kind of unit that is there.
That's fantastic. Okay. Well, on that note, I think we're out of time. So I'm going to say thank you to I'll leave this alone. Thank you again to Professor Noxon for a really interesting talk.